Hey guys, I'm gonna just do a little bit of this final review to help in case you're confused and don't have any resources. I have no idea how long I'm gonna go before I quit, so let's find out. This first one, evaluate always means find the number answer. Oops, I didn't send this to Notability, so now you can like hang out with me. Actually, I think I did. Let's check it out because apparently being me is really hard. There we go. There, now I can write on it. So evaluating means that you are going to be finding a value, and finding a value usually means that you're plugging something in. So in this particular problem, I'm supposed to put a -2 in for the x, and it's essential to use these parentheses because then your calculator knows to square this whole -2, turns it positive, and so on. So this is kind of PEMDAS, but you have a calculator, so use that to help you through, and you should end up at B. Here you're going to do the same thing, except you're putting in, oops, it's not negative, sorry. You're putting in a 4, it says. So everywhere there was a 4, you're putting, everywhere there was an X, you're putting in a 4. So far, I feel like this video is really helpful. And then you are going to run that through your calculator as well. And that's going to get you 197. Okay, simplify usually has like 3 elements. It means that sometimes you have to FOIL, sometimes you have to distribute, you have to combine like terms. So that's what simplifying means, like do that kind of stuff. In this particular problem, I'm going to distribute the 3, so I'll have 3x minus 6. What's tricky about this, and people always forget, is you got to distribute the negative along with the 2. So here the negatives cancel and you get a positive 8. Then I'll combine like terms. 3x minus 2x is 1x, and then -6 plus 8 is a 2. It's a really easy one to get wrong. And so what did I end up with? X plus 2, so my answer is A. And on the review, it's like not that big a deal to find the answer. It's like figuring out what to do so you can do it on the final. Same exact thing here, distributing there, I'll get a -4x and a -8. Distributing here, I'll get a -3x, but a positive 21. And so when I put the like terms together, these two are alike, and then these two are alike, meaning just numbers. So -4 minus 3x is -7x. Oh, I guess this one's not multiple choice. And then -8 plus 21 is going to turn into a positive 13. All right, a baseball team is selling flowers for a fundraiser. The flower shop charges $15 per plant and a one-time charge of $70 to set it up. How many plants can they purchase if their budget is $14.20? So we did a lot of work with y equals mx plus b, where b is going to be the starting amount. Like when we graph, it's where they start on the y-axis, and this is going to be the rate, and then this is what you have in the end. So this particular problem is saying that in the end, we'd have $14.20. Our rate of change is $15 per plant, and per is kind of the indicator that it's a rate. And then a one-time charge is 70. So it starts off being $70. And so then I'm going to take away the 70. And when I take 70 away from this other side, I'm going to end up with $13.50. Excuse me, felt that coming on. And then I'm going to divide both sides by 15. And I'm going to end up with 90 plants. And so that is going to be letter C. Youth group is selling books for a fundraiser. The bookshop charges $10 per book, so that's probably my rate, and a one-time charge of $80, so that's my B. This is the exact same setup, so $12.80, and I'm paying $10 per book plus an $80 startup fee. So if I take that 80 away from both, I'll have 1,200, and that'll equal 10x. So dividing out 10 in both cases, I'm going to end up with 120 books. All right, solve for y means get y alone. It means move stuff around until y is by itself. So I have 4x plus 5y equals 20, and I'm going to try to get this y alone. So you start by moving things that are farthest away from it. So in this case, that would be a -4x. 5y equals negative 4x plus 20 is going to get the x over the other side, but now I need to divide out the y, and it's easiest if you just do it by each piece. This turns into y. This stays negative 4 over 5x, and then 20 over 5 at the end. This piece will reduce down to be a 4. And if you're not great with that, you have a calculator to help you. So then you will be great with that. So that matches answer C. And boom. Solve the equation for y. Okay, same exact process. Like I told my class, we kind of were tasked with coming up with 2 problems that would help practice for the test. So it's telling me there's probably one like this on there. So to get this y alone right here, I'm going to start getting the other stuff moved over. So I'm going to add 2 x's to the other side. Negative 3y equals 2x plus the 6 that was there. They don't go together because the 2 has an x and the 6 does not. And then I just zoom through and divide each piece by negative 3. So y equals, this is a negative 2/3 because the negative can go anywhere, but it looks weird on the bottom. And then this, according to your brain and or your calculator, will reduce down to a negative 2. And that one's not multiple choice, so I just leave my answer. Okay, so now, sorry. I guess it really doesn't matter if I write my answer over there, but that's apparently what I'm going to do. All right, so now I still am solving, but this one has an inequality. And keep in mind that in that situation, there's one difference in that it's you need to flip the symbol from greater than to less than if you multiply or divide by a negative. So if we multiply by a negative or we divide by a negative number, we're going to need to flip the symbol. If we don't, it's kind of just like solving. So if I start here, I'm just copying it so I have room to work. I need, if you think about like the railroad tracks they taught you forever ago, I'm going to always get the letter to the left side, especially when I'm doing inequalities. Negative 3 minus 2 more is actually negative 5. I still have the 7 here, and I still have the negative 3. I'm going to move the 7 over. So now I have negative 5b equals negative 10. Here's the moment of truth. Not equals. It is greater than or equal to. I'm going to divide by negative 5. Nothing in the universe except for your brain is going to make sure that you know that you got to flip it. But you're dividing by a negative 5, and when you're dividing, you need to flip the symbol. So this becomes less than or equal to a positive 2. So that is going to be A. And if I had to graph that, remember, I would have on my number line, I would have a 2. Since it's or equals to, I'd fill it in, and then less than would go off to the left. All right, we'll kind of think about it the same way here. I'm going to move the x over by addition. I have 6x minus 2 less than 4. I add my 2. I have 6x less than 6, and I divide by 6. Now here I don't have to do any flipping because I am not dividing by a negative. So I get that x is less than 1. If I had to graph this, remember this one, I'd say, okay, here I am at 1, but because it's less than, not equal to, I'm going to keep that open and then head off to the left for less than. Okay, now these are tricky. Solving absolute value inequalities means I need to have my x minus 4 equals 6, but that means inside here I could either have a plus or minus 6 in order for it to be 6. So what I do is I take what's in here. I used to always tell my classes 2 bars mean you're going to get 2 answers. So I'm going to take my x minus 4, set it equal to 6, and I'm going to take my x minus 4 and set it equal to negative 6. You never change what's inside the bars. You always keep that the same. But you're saying, hey, whatever's in there could be a positive or a negative 6 because the absolute value of both of those numbers comes out to be the 6 that I need. So I get to solve both of these. So I solve them the same way. I add 4 to both sides. Here I get a 10. Add 4 to both sides. Here I get a negative 2. So these are the 2 options. So I get a negative 2 and a positive 10, which is going to turn out to be choice B. All right, let's try that again. Now, whatever's in here could be either positive or negative 7 in order to come out as a 7. So I take x plus 4, let it equal 7, or the other option is x plus 4 could equal negative 7. And then I just solve. I'm always going to take the same solving steps in both cases. And I'm going to get x equals negative 11 because negative 7 minus 4 more. So those are my two answers for this problem. X equals 3 or negative 11. Okay, domain. The concept here is domain. And what domain asks us to do is to find the input or the x values. And so I'm just looking at my x values. And they are 4, negative 2, and 1. So that matches here. So that means my answer for that one is C. Range is always going to be your y values. Domain and range, think of that alphabetically. D comes before R, and then X comes before Y. And then that is just asking me to look at the y values. Will I get negative 2, positive 3, or negative 3? It doesn't really matter what order they're written in, but it would be negative 2, positive 3, negative 3 are like the y values that I have. Find the slope of the line. Okay, well, slope is going to be, if I have 2 points, y2 minus y1 over x2 minus x1. And that's a formula you need to know or have on your cheat sheet. So this is going to be the first x, first y, second x, second y. So my slope is going to be the second y minus the first. So this minus is a part of the formula. And then the reason that my 5 is negative because that's what it was in the coordinate. So ultimately what happens there is these cancel out and become positive. Now on the bottom, x2 minus x1, there are no negatives. So on the top I have negative 7 plus 5, and on the bottom I have 5 minus 2. So I get a slope of negative 2/3. This one's a multiple choice, and that matches with A. Here I'm doing the same thing. So this is going to be my x1, y1, my second x, and my second y. So negative 4 minus, now I go over here and I subtract my first y. Then I do my second x minus my first x. On the top, I get negative 11. You can use your calculator to help with that if you get lost and confused. And on the bottom, I get a positive 3. So if I was graphing, it would go down 11 and over 3. And you don't want to change it to a decimal or anything because that's weird for slope. Okay, so here the concept is, what about the slope of a line perpendicular to another line? Perpendicular lines cross at 90 degrees. And in order to do that, their slopes have to be opposite in sign. One's positive, one's got to be negative because one's going up, one's going down. And then they also have to be reciprocals. So you flip over the fraction that you have. So first I need to figure out what is the slope of this line, and the answer is that the slope is 2. I need the opposite reciprocal. Well, if you have 2 over 1, you need 1 over 2, and if you had positive, you need negative. So my option that matches that is going to be choice B. And then the same concept here. I'm still looking for perpendicular slope. This one has a slope of negative 3, 4. So I'm going to need the opposite, so positive, and then the reciprocal, so flipped over. So I'm going to have a positive 4/3 for my slope there. Okay, let's graph. So this is going to be the whole mx plus b thing. This is going to be where it crosses the y-axis. And this is going to be how you move. I always think slope is m for move. You're going to move up because it's positive 1 and then over 7. You always go over to the right. So we need one of these that crosses at 2. This one, it crosses the y-axis. The y-axis is right here, smack dab down the middle. This one crosses it at 0. This second one is going to cross it, it looks like, at 2. So that's a good start because I need it to cross the y-axis at 2. This one crosses at 2, and this one crosses at 2. Now, I'm going to actually get rid of this one because this one has a negative slope. It's going down from left to right, and mine has to go up 1 over 7. If you look at the two that remain, up 1 over 7 is not going to be very steep. And so here, this one does go up 1 over 1, 2, 3, 4, 5, 6, 7. So this is the one I want. This one is 1 over 7. I think what they did here is they went up 7 over 1, so that made it really steep. So this one's using a slope of 7. So that one's going to be my best answer, so that's going to be D. All right, so this one's going to start at -3 on the y-axis. So I go to my y-axis, and I go to -3. So down 1, 2, 3. And then this M tells me how to move. So I'm going to move down because it's -3 over 2. And you're always moving to the right. So I'm going to go, well, that's terrible because it goes off the graph. Down 2, 3 over 2. And if you want to go backwards, you could go up 1, 2, 3, back 2, if that makes sense to you. But you got to get enough dots that you can sketch your line in pretty accurately. And then that is the line of that equation. All right, so all of this is off that orange chart we did in chapter 2 if you're in my class, slope, intercept, form. These are different forms of the line. Actually, that's not true. The orange one I think was for quadratics. So slope, intercept, form is my y equals mx plus b. So I need m and I need b. And we talked in a chart. I feel like maybe it was a blue sheet of paper. I don't know. I make them different colors. There's 4 ways to find slope. And then we used one of 2 ways to find b. So this particular problem, we don't have to find the values. We just have to move stuff around, just like we did earlier in this review worksheet. Slope-intercept means the y starts off by itself out front. So we're just going to move stuff over like we did in the earlier problems when it said to solve for y. That's gone. 14y is going to equal the -3x minus 24. And I put the x part in front because that's how slope-intercept goes. Then I'm going to divide each piece by 14, just like we did in the earlier problems. I'm going to reduce if I can. So like in this case, I get y equals -3 over 14, but then this is going to reduce because you can use your calculator or however you want to. Wait, why did I get a 14? Oh my gosh, I couldn't read my own writing. So if I lost you, I apologize. That should have just been a 4. So all of these would be 4s. I, back here, decided part of my adding sign was a 14, so I made that really tricky. So what I'm doing here is dividing each part by 4 instead, which makes my problem significantly less weird. And so here, I'm going to have -3/4 x, and then 24 over 4 reduces to 6. So that's going to be my line. Oops, multiple choice. So -3/4 minus 6 is choice B. Okay, I'm doing the same exact thing. So 5x minus 7y equals 14. Maybe that's where I got 14 from. Who knows? I'm going to move this guy over. I always move the x over, divide by the number with y. So now I have -5x plus 14. I don't put them together because they don't both have x's. And then I just go through and divide that -7 out. So I get y equals, in this one, can you see that the negatives would cancel out? So it turns into 5/7 x. And then this on your calculator or in your brain is going to reduce down to a -2. Okay, y-intercept and x-intercept, that is like where everything crosses the x or y. That only happens when one of your coordinates is 0. So this is when I used to do these tables. I would put a 0 in for each one. The one here is going to find you the y-intercept, the one here is going to find you the x-intercept. So if you're trying to find the y-intercept, you put the 0 in for x. If you're trying to find the x-intercept, you put the 0 in for y. So I'm going to do that, except for this is only asking for the y-intercept, and the y-intercept puts the 0 in for x, so I'm going to do this row. So I go to my equation, and I'm going to put a 0 in for x and get an answer for y. Well, 5 times nothing is nothing, so I'm going to divide out this -6, and the y-intercept will be at -5. So 23 is A. The x-intercept is going to mean I get a number here, so I'll need a 0 here. I'm looking for the x-intercept. Okay, so now I put the 0 in for the y instead, so that my answer is an x. That's the x-intercept. We'll have an x in the answer. So here I would need x to be 8. So that means that if I went to 1, 2, 3, 4, 5, 6, 7, 8, 0, I would have a point that would be considered my x-intercept because it's on the x-axis. Intercept means cross. So that's where it crosses the x-axis. I think I will go to 30 and then stop this video, and then I'll make a different one. Okay, now there's a couple different ways to graph this. I do it one way, and I know a lot of you guys like to do it the other way. So I'm going to show you my way and then do your way. My way, for lack of a better term, is to do what I just did. Put zeros in, and I'm putting it in a place where I can't even show my work. So I'm going to scoot that chart over here. So let's say I want to do just where it crosses x and y. 0 here, 0 here. If I do 3 times 0 plus 7y equals 21, I only have this left. And when I divide by 7, I get a 3. When I put the 0 in for y, I'd have 3x plus 7 times nothing equals 21. That part 0. And when I divide by 3, I get a 7. So this is telling me that I need 0, 3, which this is not because this one's negative, so that's not it. 0, 1, 2, 3, so that's possible. And then I go out 1, 2, 3, 4, 5, 6, 7 to the right. So this does cross the y at 3, and it does cross the x at 7. So this is actually going to be my best choice. The other way you can do this, but I just find this to be so much more confusing, is I can solve this for y. A lot more work in my opinion. Plugging in 0 is easy. Now I divide by 7, but then you got to graph -3/7 x plus 3. So you got to find one that starts at 3 on the y-axis, which would be this one and this one. And then you need to go down 3 over 7, which you could figure out is down 3 over 7 right here. It doesn't really matter which way as long as you have a way that feels comfortable to you. I am going to still do the same thing. I'm going to use my intercepts when it's in standard form like that. So put a 0 in for x. We'll cancel this out. Solving this one with the -3 on each side, we'll get a -2. Then to get the other y-intercept, I'm going to put, to get the x-intercept, I'm going to put a 0 in for y. Well, if I put a 0 in for y, this part disappears, and I'm left with 2x minus 6. So when I divide out my 2, x is 3. So now I am going to connect 0, -2, and 1, 2, 3, 0. I'm going to connect that and call it good. Okay, here we are going to do slope-intercept form of the line, passes through here with a slope of this. So I did this a way that might be different than other teachers. We used that point slope formula where you would go y minus the y1 in the point equals m times x minus the x1 in the point. So you would have these three values. you would have your y and your x from the point and the slope if it's given to you or however you find it. So in this particular problem, this is my slope. So, and then I would use these two numbers as my x and y1. So here I'm going to do y minus y1 equals my slope, which they gave me was -3, times x minus -5, because that was my x value. But that would turn positive. So I get y minus 5 equals, and then distributing here, 3x minus 15. I'm going to add 5, and I get y equals -3x minus 10. Now, some of you don't do it that way. Some of you go, well, I have y equals mx plus b. I'm going to put my y here, my m here, my x here, and then plus b. This is going to turn into positive 15 on my calculator or in my brain. And then I'm going to take it away. B is going to turn out to be -10. Then I take this element, and I stuff them into my mx plus b format to get the exact same answer. So I don't know which way makes more sense to you, but you should probably do it that way. All right, this is the same Z's, so I'm going to do it real quick both ways. Y minus my y value will put me at +4 equals slope times x minus my x value. Going to distribute my 2 every time, and then move this number over. So y equals 2x minus 10, or if you like the other way, you can go ahead and put your y value in here from the point, the slope they gave you in here, the x value from the point. And so I'm here right now. Santa's here, it sounds like. I hear sleigh bells. So then my b turns out to be -10, which is weird because it was in the problem before that too. But then I would put that in for my b, and this m they gave me in for the m. So I don't know which way your teacher did it, but that is either route gets you where you're going and should land you at the same exact answer. All right, I'm just going to do these last two. This is still mx plus b. You have a 4-inch tall, and it's burning at a rate of 2. So what you know about candles is if this is what it starts at, this is going to be decreasing because it's going to get smaller. So it's going to go down by 2. So this is my start value, and this is my rate of change. So I would write y equals mx plus b. This is my rate or my slope, rate of change. This is my start number. And so then that matches with C. And then the last one for tonight, the starting wage, so that's going to be your B, because you're starting at that value. Annual raise, so that's going to be going up by 2 as your M value. So write the linear model is wage after X years. Okay, so you will make 2x plus 15 because you started with 15 and you go up by 2. So that's going to be just the first 30. Hopefully that helps you get a good start.